We have finished learning how to determine the derivative when we are given an equation or a function. So now we need to start looking at what we use derivatives for and what purpose they serve. So let me first take a few minutes to do a quick review of sort of the whole concept and idea of what a derivative is, and then that'll help us to see how it can be used in a practical way and how it's used in the world of math and science and all kinds of educational fields. So one of the key things I keep emphasizing in class is we've learned about this word called the derivative, but in my mind, whenever I think of derivative, I always think of slope. And when I think of slope of a line, furthermore than that, I think of the steepness of a line. I talked about in class, probably the first time any of us learned about slope, we learned about slope of straight lines. The slope is how steep this is. The slope was a number, and for a straight line, the slope is constant. There's only one slope for this straight line. And since it rises as you go from left to right as the slope goes up, this was a positive slope. Here's another line. The slope is still positive, but the slope would be smaller than this one because it's not as steep. And then in the same way, you can have lines with a negative slope. So as I go from left to right on this graph, since the line is going down, this is sort of the old X and Y, since the line is going down, this would be considered a negative slope. However, what we began to look at, to look at functions or graphs that weren't just straight lines, but that were curves. And then we began to think about, well, how could you talk about the slope of something that's a curve like this? If you think about it, as you go along here, as you move from left to right, obviously it's a positive slope going up. Now, in terms of derivative, we began to talk about how, since this is a positive slope, we also say it's a positive derivative. And you know what? A lot of times, instead of graphing y, we begin to think about graphing functions, y and f of x. Remember, really sort of mean the same thing. But if we think about this as the function, the graph of a function, a lot of times we would say here, the function's increasing, the function we measure on this y-axis, the function's increasing, we say the slope is increasing, and we say the derivative is positive. So think about the slope, it's a positive slope, and then but the slope is changing, because all of a sudden here, the slope, the curve, is not quite as steep. As a matter of fact, once we get to sort of the top, or this maximum point, it's really flat. Because then next thing you know, all of a sudden the curve is going down and the function's decreasing, which means all of a sudden the slope is negative, which means the first derivative is negative. So in terms of the first derivative or the slope, we can think of the first part of this graph, the slope is positive or the first derivative is positive. We get up here to the maximum, and actually what we say about the slope here, the slope or the first derivative at the absolute top of this curve is actually 0. And once again, we talked about the idea about looking at the tangent line to the graph. Remember, the tangent line is a line that touches the graph at just one point. If I were to draw the tangent line at the top of this curve, it would be horizontal, and the slope of this horizontal line is 0. And the slope of the horizontal line is the same thing as the slope at that point. So if we keep on going, what happens once we start to go down? The function decreases, the slope and the first derivative become a negative because now we're going down. And look what happens when we get to here. Once again, as it bottoms out, we call this a minimum. You know what happens again? The slope at that point is 0. And then we start to go up again and things turn positive. So what's really going on? In terms of the function's increasing, the function levels off, the function begins to decrease, it levels off again, and then the function begins to increase. If we talk about the slope, we have a positive slope here, positive slope. The slope is getting smaller, but still positive. Finally, at the top here, the slope actually goes to 0. It's not positive anymore, it's 0. And actually, then what happens is, because our function starts to go down, the slope becomes negative. And the slope continues to be negative until we get to this point. And the slope goes back to 0 because it's sort of horizontal. And then the slope becomes positive. And finally, if we talk about the derivative is positive here. The derivative at this point is actually 0. The derivative all of a sudden in this middle part is negative. The derivative goes to 0 at the bottom again, and then the derivative becomes positive. So hopefully, once again, this is sort of a review. You can see the idea that a derivative means the same thing as slope. And when we have curves here, the slope is constantly changing. When we were looking at straight lines, the slope of a straight line doesn't change. It's the same the whole time. But here, it's constantly changing. Now, so far in math, in this class, we like to talk about graphs a lot because visualizing things can help our understanding of slopes and derivatives and functions. But then also, we have to know how to work with functions, or sometimes we call them equations. So a lot of these concepts, when we're talking about derivatives and maximums and minimums, when you look at the graph, it's very easy to see, very easy to answer questions you have if you're given a graph. But if you're given a function like this, I'm just sort of making up, here's a function or an equation, and maybe you're given this function and you're not given a graph, you're just given this function, and you're asked questions like, where is f of x increasing? In other words, what are the values of x where the function's increasing? When I have a graph, it's very easy to see. It's increasing from negative infinity to right here, and from here to positive infinity. There's two regions of this graph where the function's increasing. There's one region where it's decreasing. But when you're just given a function or an equation like this, and you're asked this question, we have to figure out a mathematical way to answer this question. And the answer to this question is going to be some kind of an interval, right? An interval is, you have two values in here. You have the low value and the highest value. So for instance, if I was to do the interval for this graph here, say this here is -1, and maybe I call this point 4, I would say the increasing is from -infinity to -1. So I would say -infinity to -1. So these are the values of x. So when x goes from -infinity to -1, that graph is increasing. But I also have this part of the graph is increasing. So then I would say then also there's a second interval, starts at 4, and it goes to positive infinity. So these are the intervals, looking at this graph where it's increasing, and if we ask about where is it decreasing, there's only one region here. We would say it's decreasing when x is between -1 and 4. So here are the increasing and decreasing intervals for this graph. However, what I want to do is to take this functional equation and answer these same questions, except I'm not going to have a graph. I want to be able to mathematically take this function, this equation, and answer these questions. And these are actually not the only questions. You're going to be asked the question, where's the function increasing or decreasing? They'll also say, where is the first derivative positive and negative? And once again, the answer is going to be an interval. So they're saying, okay, given a function, where's the first derivative positive or negative? Well, what's interesting is this question up here, where's f of x increasing, is really the same question as where is the first derivative positive. Once again, let's look at this graph. Here's the section where the function is increasing. This same piece of the graph is where the first derivative is positive. So those are synonymous. An increasing function is the same as a positive first derivative. You go over here, here's your increasing function, here's where the first derivative is positive. And then they say, where's the first derivative negative? That's the same thing as saying, where is the function decreasing? So we would say this middle part is where the function is decreasing. This would be where the first derivative is negative. So hopefully, once again, this is sort of review kind of stuff. But what we're really wanting to do now is to look at an equation and to be able to answer these kinds of questions. Now, another big part of this section is, besides answering these kinds of questions, we have a couple special points in this graph. And I've mentioned it before. This point right here, the very top of this curve, it's pretty obvious, hopefully. We like to call that a maximum. And if we have a point that's at the very bottom of this curve here, pretty obvious, that's called a minimum. Once again, sometimes you'll be asked a question. For this function, for this graph, where's the maximum and where's the minimum? When you're looking at a graph, it's pretty obvious. Here's the maximum, here's the minimum. Sometimes they will say, what are the values of x for any maximums, and what are the values of x for any minimums? Now, if you're looking at a graph, if we're looking at the maximum, for this one, you would say, I have a maximum when x is equal to -1. So when x is -1, here's my maximum. For that graph above, I would say the minimum occurs when x is 4. Sometimes they might say, instead of saying what are the values of x, they say, actually give the point of the maximum or minimum. The point means both the x and the y. So sometimes they will ask you that question. So for this one, we would say the maximum would be the x is -1, and say I go to here and I say that right here is 10. So the value of the function, or the value of y or f of x, would be 10. And this one, say this point here, I call, 4. So the minimum would be the 0.44. So once again, if I'm looking at a graph and I'm asked to give the maximum and minimum, very simple problem. You just look and you find these points and you're good to go. However, a little more work is to be given an equation or a function. You're not given a graph. All you're given is this equation. And you're asked, okay, for this function, what are the maximums and the minimums for this function? And we have to know mathematically how to come up with these answers. So that's the kinds of things we're going to talk about in this section. And we're going to use the first derivative as a tool to answer all these kinds of questions. Now let me talk a little bit about, in the world of math, sometimes there are definitions and the way things are worded, and sometimes there's the absolute sort of legal definition, and then sometimes there's the words that we just commonly use when we're working out problems. So this is a case of that. So let me talk about, they use this word in books. Here's a nice math word. They call it relative extrema. How about that for a nice math word? What that means is, to make a little clearer, extrema means either maximums or minimums. So really, relative extrema means either relative max or relative min. And once again, I'm going to start using the word max and min instead of maximum and minimum, just to save my breath. So relative extrema, we're talking about relative maximum minimum. The reason these are relative is because there's a second kind of maximum minimum. And we're going to talk about this more later on, but let me just introduce it now. There's what we also call absolute maximum and a minimum. So these are two kinds of maximum and minimums. Now let me say, I'm going to describe the difference between these two, and then I'm going to tell you when I talk about this stuff from now on how I'm going to talk about it, so you're not confused. So for now, let's just look at a few graphs. And let me quickly describe to you the difference between relative maximums and absolute. First of all, oftentimes when we draw graphs, sometimes even in class, I'll just draw a graph like this. And let me tell you, when you draw a graph like this, hopefully most of the time I put little arrows on the end, because these arrows mean that this graph, sort of goes on forever, as opposed, if you see a graph like this, that means this graph actually stops right here. It does not keep going on. The problem is sometimes, even when I draw a quick graph in class, I may just go like this, and I don't put arrows or dots. Typically, if it's like this, usually it means it goes on, and we just don't put the arrows down. Usually, if they want the graph to stop, you see definite sort of dots here at the end. So that's the first thing. So let's look at a graph now, a couple graphs, and let's talk about maximums and minimums. What if I start here and here's a graph of a function. I call it y. I could have called it f of x. Once again, those are the same. 4 questions. Look at this graph. Absolute max, absolute minimum, relative maximum, relative minimum. All right, so let's talk about this. Absolute max, absolute min. Absolute max means you look at the whole function, the whole graph, and you say what is the absolute largest value that the function ever gets to. In this case, what's the highest the graph ever is. This right here, that point, is the absolute max. There's no other place on this graph that ever gets as high as this point right here. And in the same way, if you look down here, that point would be the absolute minimum. There's no other place on this graph that goes as far down or goes as low as this point right here. So then what are relative maximums? Relative maximums means, earlier when we talked about graphs, I called the highest point here of this little sort of hump or this curve, I called it a maximum, because when you're looking in this area of the graph, this thing sort of maxes out right here and then it drops again, so we call this a maximum. Legally, in terms of the math world, this is really called a relative maximum, because relative means it's conditional, meaning this is the maximum point for this part of the graph, but this is not the maximum point for the whole graph. The maximum point for the whole graph is over here, which is why we call this point the absolute maximum. We like to call this point a maximum, and it is a maximum, but it's a maximum for this part of the graph. We say this is a maximum relative to what's going on here, which is why it's called a relative maximum. And down here, earlier I called that a minimum, which is fine. It would be really more correct to call this a relative minimum. In other words, this is not the lowest point on the graph. That's over here. The absolute lowest point on the graph, I just said it, it's called the absolute minimum. In this part of the graph, I do have a minimum because my graph is decreasing, and the farthest down it goes is right here, and then it starts to come up again. So I like to call this point a minimum, although really it's more proper to call it a relative minimum. But here's the deal in the world of math, just because sometimes you get tired of saying all these words again. When we're discussing problems, if we're given a function or we're given this graph and you're told find the max and the mins, really what they're really asking for are the relative max and mins. When you're given a problem and they say find the relative max or find the max or min, they're really asking for the relative max or min. If they want the absolute, they would usually say absolute. Now in the book, they're probably careful to always say relative. But in class, I'm just telling you now, I'm not going to say relative max and relative min all the time. From now on, as I'm doing problems, if I say what's the max and the min, I'm really talking about relative max and min. There will be a section, a couple sections from now, where we actually will determine absolute max and min and relative max and min. But that's just one section. Most of the time when we talk about maxes and mins, we're talking about relative. Now just out of interest, let me give you a couple other graphs just to make sure you understand the idea about absolute and relative. What if we ever had a graph like this, and we were asked, go on here and point out the absolute max and min and the relative max and min. Well, absolute max and min. Well, I got this point here. Is this the highest point on the whole graph? Actually, it's not, because look at over here. When I get over here, it's actually larger or higher up than here. So really, this point is the absolute maximum. And you know what? And it's also the relative maximum. Once again, a relative maximum is the idea it's like the top of a curve. They like to call that relative maximum. But as it turns out, since the maximum point here is actually the highest of the whole graph, it's actually both. What about the absolute minimum? Well, I got a minimum here, but then I notice over here, this is a lot farther down. So here's my absolute minimum. This would again simply be a relative minimum. Same questions. Absolute max and min, relative max and min. Hopefully it's pretty clear. Absolute max, absolute min. Now I'm asked for a relative maximum, a relative minimum. There aren't any. Relative maximum is always when you have a curve that goes up and then comes down, and there's the maximum. A relative minimum looks like this. We don't have either of those here. All right, so let's go ahead now. I'm going to stop this video and start again, and now we're going to start looking at mathematically how to determine maxes and mins, and when the function's increasing or decreasing, or when the derivative is positive or negative.